talk about generics today. So let's start out by creating a class, and this class we call myCollection. And what we'll create here is really just a collection of strings. And internally we define a member variable of type string array, and we call this array. And let's add a constructor to it where we pass in an array and we assign it to the same name member variable. And we add a couple more methods. Let's add a method called add, where we add an object at a specific index. So we access it at index and we assign the string object to it. We also create a method length that returns the length of the array, and another method get that returns a string at a specific index. And this is our class. Now we can see this class can only handle strings, and everything is fine as long as we just need collection of strings. But let's say we need now a collection of integers. Obviously this class will not be able to handle this, so we would have to create a new class with the same structure of the code. The only thing that really changes is the element type of our array. So we would replace string here, replace it here, here, and here with an integer. Now if we need another collection, and this time maybe of another type, maybe car, again we would have to create a new class and replace this type in the new class again with the object type that we want, for example a car. So we would duplicate the code even though the code essentially stays the same. And this is the exact same purpose why we want to use generics. So let's take a look at generics. Generics, like the name implies, is a generic placeholder. So in this case we want to have a placeholder instead of specifying the exact type here. So we want to use a placeholder here, 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 and here. And the way we do this, we add it to the class definition. So here we just put T for type, but really it can be anything. We could even name it placeholder or anything else. But the standard is really just put in T type. And now we can use this placeholder anywhere where we need in our entire class. So we can put it here, here in the constructor, in the add method, and here as a return type for the get method. Now what this allows me is really create a collection of an element type that I select. So if we add a main method at the bottom, public static void main, and now we create an object of this collection, we can again specify the generic type here, but now we select a specific type. So let's say we want to have a collection of strings. We call it strings, we call the constructor, and in the constructor we create a new array of say 10 strings. So this is how I define a specific type for my generic type definition. Now I do strings.add, and you can see the IDE already suggests I can add at an index, but I can only add an object of type string. And if I now need a collection of type integers, I can reuse the same code and the same class. I just specify now I want to have integers. And when I call the constructor, I pass in a new array of integers. Again 10. And when I do integers.add, we can see now I can only add integers to this collection. Now this is the power of generics. So we use the same code, but we have some placeholders in the code where we define the type at the time when we can actually create an object. The generics can really be used on classes, and they can be used on method signatures as well. And we can even add complexity here. Let's say when we add an extends keyword, extends, for example, animal, when we have an animal class, we can say we only want to allow objects of a class that inherits from animal or that is animal. But we look into that another time. So thank you for watching. I hope you have a better understanding of what generics are, and see you next time.